Okay, so continuing our series on geometry and the geometry videos. We've looked at just some review situations yesterday in terms of parallel lines and triangles and angle sum of polygons and that sort of stuff. So that's where we're up to. Today we're going to be a little bit more specific about our work, and we're going to move into an area that perhaps you haven't seen before, and that is congruent triangles. Now this word congruent, this word here, means exactly the same, equal to, and it's used for describing shapes as the same. So we don't say shapes are equal, we say they're congruent. So they're exactly the same size and shape. So we should just write that down here. Exactly the same size and shape. So you can put one on top of the other. They're exactly the same. And triangles don't need to explain what they are. Okay, hopefully. So right. So let's have a look at what this means. If two triangles are congruent, let's just have a look here. If I draw a triangle there, and then maybe we'll draw in a different orientation just to mix things up a bit. But let's say that these two triangles here are congruent. Therefore, what we can say is that the opposite sides, so the corresponding sides, so I'm trying to work out what I've actually done with this. So that side there corresponds to that side there. That side there corresponds to that side there. That side there corresponds to that side there. Okay, so they're congruent, means that all the sides of the corresponding sides. So this is a word that we're going to use a lot. Corresponding. So they are corresponding sides. What that means is they're in the same position. Corresponding sides on different triangles. So they're corresponding sides. These two here are corresponding sides, and those two there, they match up. So if they're corresponding sides, then the angles that are opposite those sides, so this angle here is corresponding to this angle here. This angle here opposite the two strokes is corresponding to that angle there. And finally, this angle in here and this angle here are corresponding angles. So let's just get some of this language straightened out so that we're all okay. That is referring to corresponding angles. Okay, so if we know that two triangles are congruent, then what we can say is that they've got three pairs of equal sides and three pairs of equal angles. Okay, so so if two triangles, I'll try and write a little bit neater today, are congruent, they will have three pairs of equal sides. Those sides are in corresponding positions. Three pairs of equal sides and three pairs of equal angles. So that gives us a total of, therefore, a total of 6 equal statements. Equal statements. So we've got a total of 6 equal relationships, 3 sides and 3 angles. You get it? Okay. So what we're going to do here is, what we're going to do in this area is we're going to look at proving two triangles congruent, which would be absolutely nothing at all to it if we got all 6 bits of information. But we're not going to get 6 bits of information. We're going to get typically 3 pieces of information, and from those pieces of information we have to prove that we've got two congruent triangles. Okay, so there are three ways of doing that. SSS, SAS, RHS. 3 different ways of doing that. SAS, AAS, sorry, there's 4. I've missed one, AAS. Okay, so there are four ways we can prove two triangles are congruent. Exactly the same in every way. There are 4 ways. Right, let's go through them. One is called the SSS rule, side, side, side. So what this one says is that if I've got, let's get the if I got this information here, if I've got information that three pairs of corresponding sides are equal, so that side and that side, that side and that side, and that side and that side. Remember I said we're going to be given the 3 bits of info. Well, if those 3 bits of info are that, we can go ahead and confidently say, right, well, these two triangles are exactly the same, they're congruent. There is no way I can take that information and draw two different triangles. It's impossible. So if we have that information, so 3 pairs of corresponding sides are equal, then what that means is that all these, that means they're absolutely exactly the same, which means therefore we've got 3 pairs of angles that we didn't have given to us, but we can now deduce that we've also got 3 pairs of corresponding angles equal. So that's the side, side, side. That's the most straightforward one. Proof 2 is SAS, side, angle, side. Side, angle, side. Right. In side, angle, side, as it suggests, we're going to be given 2 triangles, and we've got some information about those 2 triangles, and this is the information. That side equals that side equals that side, and this angle equals this angle. Okay, now they're in corresponding positions. I've drawn them conveniently in the same orientation, so that makes it nice and easy. And there is no way there's no other way of drawing those 2 triangles with that information. They have to be exactly the same, so that will prove congruence. That will prove congruency. So with that information, side, angle, side, the important thing here is that the angle is between the two. Angle between the 2 sides. See how it's between the 2 sides make up that angle. So it's called the included angle. The included angle. Okay, so you could have side, angle, side, but if the don't write this down, that's alright, I'm going to get rid of this in a sec, but if we were given, or let's say 2 triangles here like this, and we said, yeah, that's equal to that, go for it, that's equal to that, no worries, but this angle and this angle are the same. Okay, I've got 3 bits of equal information. I've got 3 equal statements. This equals this, this equals this, this equals this, but they're not in the configuration we need, because I could conceivably draw 2 different triangles with that information. So this does not prove congruency because the angle is not included. So no good there, has to be in there. Okay, so keep that in mind as we go forward. Okay, number 3, method 3 of proving congruency is AAS, which is angle, angle, side. Now in this case, 2 angles. We've got 2 angles, so here we go. I'll draw some different triangles up. This is an obtuse angle triangle, which you will know from yesterday's work. Right, there we go, 2 triangles. Now I'm going to give you some information here. I'm going to give you 2 angles. So I'm going to say that angle and that angle are the same. That angle and that angle are the same. Actually, that means that this angle and this angle have to be the same by angle sum. But just because 3 angles are equal to each other, 3 pairs of corresponding angles are equal, does not mean we've got congruent triangles, because one could be just a reduction or an enlargement of the other, in which case they're similar triangles. We'll come to that later in this chapter. But no, we need 1 pair of corresponding sides to be equal as well. Now, if I've got that information, that means these 2 triangles have to be congruent now. 2 angles and a corresponding side equal. Right, that's 3. And 4 is what's known as right angled hypotenuse side. Right angle hypotenuse. So this is a special case of 2 sides and an angle. It's a special case for right angle triangle. So if we've got a right angle triangle, okay, then we need to look for this particular test for congruency. There's the right angle hypotenuse. Right, well, that hypotenuse is equal to that one, and then one of the other sides. So that one equals that one, say. Now, if you notice, this is not SAS because it's not the included angle. There's my two sides. It's not that angle. I'm being given another angle, but because it's a right angle, it's an exception to that rule that I came up with before, where there was a problem if it wasn't included. This one's okay because it's a right angle triangle. We know, therefore, if those two sides are like that, then I will have this side by Pythagoras will be equal to this side. Therefore, I can actually go for SSS. So right angle RHS we probably don't need, because we can take those two sides, we can find the third side using Pythagoras, and we can use SSS. There are four tests for congruency. I suggest having a look at the example on page 97. Obviously referring to the textbook, the Cambridge First textbook, Year 10, Victorian syllabus, Australia. If we're looking at an example, page 97, I don't want to take up any more of your time on this video, so I'll leave it at that. Take these notes down. Then we'll have a good look in class about how to construct a congruency proof. There's a little bit of a technique involved in that. You can have a look at example 4, like I said, on page 97. And in class, we will have a look at some more examples.